evaluate the integral, example number 53, that's number 54. Example number 54, evaluate the integral t squared minus 4 all over 3t cubed plus 4t squared minus 4t with respect to t, dt, isn't it? Are we together? Now, if you look at this, for you to evaluate this kind of problem, you have to resolve it into partial fractions, isn't it? You have to resolve it into partial fractions. So what do we have here? We have t squared minus 4 over 3t cubed plus 4t squared minus 4t. That is the function we have there, isn't it? Are we together? Now after that, you can see the denominator t is a common factor, isn't it? T is common. So we have t squared minus 4 over t is common. If you factorize out t which is common, what do you remain with? 3t squared plus 4t minus 4, which is equals to what? That is t squared minus 4 over t into, see this is quadratic. Can you factorize it? Can you factorize 3t squared plus 4t minus 4? A product of negative 12 and a sum of positive 4. See that is positive 6 and negative 2. See there? Positive 6 and negative 2. Meaning we are going to have 3t squared plus 6t minus 2t minus. So the first one here we have 3t is common. Then you remain with t plus 2, t plus 2, isn't it? Then minus 2 is common. Then you remain with the t plus 2. Negative 2 into positive 2, you get back to a negative 4, isn't it? Then what is this? So it is 3t minus 2, isn't it? Into t plus 2. So it means the whole of this is the same as what? 3t minus 2 into t plus 2. Are we together there? Very good. You see, I'm insisting this method of resolving into partial fraction is what is going to work everywhere in module 2. You will start from differential equation, it will be resolving into partial fraction. So you see that, and you will see whether it is turning out to be a logarithmic differentiation, or it is turning out to be an inverse function. You see that? So you have to equip yourself with this method of resolving into partial fractions, isn't it? So let us start with the first one. So the first one, this t. See, this t is a linear factor. So a linear factor is a over, this t is a linear factor, so it is going to be over t, isn't it? See, t is a linear factor. Yes. Then the next one, 3t minus 2. See, that is also a linear factor. So it is going to be plus b over 3t minus 2, isn't it? Then plus. See, this t plus 2 is also a linear factor. Are we together? So it is going to be c over t plus 2. Is that well understood? Yes, because t is a linear factor, it can be t plus 0, it can be t minus 0. That is linear, isn't it? That is when the highest exponent is 1, is linear. So the next step, LCM. The next step is, the LCM is what you have there, which is t into 3t minus 2 into t plus 2. So you start here, we have a, t goes here how many times? When you block t, what do you remain with? That times, isn't it? It goes 3t minus 2, t plus 2 times, isn't it? So you are done with that. Then you go to your plus b, then you move 3t minus 2 goes how many times? You block 3t minus 2. What do you remain? T times t plus 2, isn't it? Yes. Yeah, you remain with b into t plus 2. Then you move again, plus c. T plus 2 goes here how many times? You block t plus 2, you remain with t into 3t minus, isn't it? Yes, you can see t plus 2 goes here how many times? If you block t plus 2, you remain with t and 3t minus 2. T and 3t minus 2, isn't it? Are we together? So what do? We compare the numerator because the denominator is the same, isn't it? We compare the numerator because the denominator is the same. So you compare this denominator is the same as this denominator, isn't it? Meaning this numerator must be the same as this numerator. Are you seeing that? Are we together? So it means our numerator, which is t squared minus 4, must be the same as this numerator, which is a into 3t minus 2 into t plus, then plus bt into t plus 2, then plus c into ct. It is ct into 3t minus 2. So you have compared the numerator, isn't it? Are we together? After comparing the numerator, what do? You see where you can eliminate t. You can now see, start with the one which is much more simpler. T plus 2 is much more simpler, isn't it? And even t alone is much more simpler when t is 0. Isn't it? When t is 0, meaning the whole of this term will go to 0, the whole of this term will go to 0, isn't it? This one was even much more simpler than anything else you've ever seen, isn't it? So, when t is equals to 0, meaning anywhere you have t will go to 0 because 0 times anything is 0, isn't it? So you can see here we have t, so 0 meaning the whole of this term will be 0, isn't it? Here we have t, meaning the whole of that term will be 0. So this side t 0 squared 0, what will you remain with this side? Negative 4. When it is 0, see here you remain with the negative 2. Here is positive 2. Yeah, so negative 2 times positive 2, negative 4, isn't it? Negative 4 times a. See negative 4a. The whole of this goes 0 because t is 0. The whole of this goes to 0 because t is 0, isn't it? So what is the value of a? You divide both sides of the equation by negative 4, isn't it? You get a is equals to? You are done. This method is very simple, isn't it? Good. Move on. We let t to be what to which can take it to 0 again. If you let t to be look here, we have t plus 2. See if you let t to be negative 2, because negative 2 plus 2 will be 0, isn't it? So we now let t to be negative 2. We let it values which are easier to work with, isn't it? Because t is a variable, can be any value, see there? Good. So when t is negative 2, what do you get? Negative 2 squared is positive 4, because both negative and 2 are squared, isn't it? So 4 minus 4 is 0, to be equals to negative 2 times 3, negative 6. No, it will be negative 2 plus 2, meaning the whole of this term will go to 0, isn't it? Then you go here is negative 2 plus 2 is 0, meaning the whole of this term will go to 0. Are you seeing that? So we'll only remain with that term, isn't it? So this term, it will be 3 times negative 2, negative 6. Negative 6 minus 2, negative 8. Negative 8 times negative 2, this which is outside, positive 16. Positive 16 times c, 16c, isn't it? Now if you have this 0 is equal to 16c, what is the value of c? T is 0. C is 0. Yes. Do you know why t is 0? Look here. See the reason why c is 0. When you have, look here, I've seen why it is 0. Don't panic. I know you can panic. You don't have to panic. T is 0 because t squared minus 4 is a difference of 2 squared. T squared minus 4 is the same as t plus 2, t minus 2. So you see this one can cancel with that. So that is the reason why you are getting c does not exist. So you can see c was t over t plus 2. Are you seeing it that this term does not exist because it has cancelled? Remember here? Yes. So it means when you make it a difference of 2 squares or not, you will still get the answers. So you just move with the normal process. Are we together? Don't go into those ideas of getting a difference of 2 squares. Those are complicating things, isn't it? Are we together? Is that understood? Yes. So this one, just let it remain like that. You will still get the same answer because this will still disappear 0 over that, isn't it? It will still disappear. So whether you let it to be t squared minus 4 the way it was, there is no problem. It will still disappear. Okay? Because majority of learners will not see it as a difference of two squares, isn't it? So we must adopt the general method, okay? Yes. Good. So you found C to be 0, making our work even more easier. That C is a simple machine making work more easier. So where you see C, that is 0. Where you see A, you put 1. Where you see C, you put 0. Work is more? Yeah, T is varying. T can be anything, isn't it? So when we let T to be 0 and negative, so you can let T to be anything now. Because we have value over C. So T can be anything, even if nothing is cancelling out, isn't it? And the best thing to choose is what? 1, isn't it? See, 1 is always the best option. Yes. Because 1 raised to power anything is always 1, isn't it? Or 1 times anything is always that thing, isn't it? Yes. So when T is 1, where there is T, you put 1. So 1 squared is 1. 1 minus 4? Negative 3, isn't it? Negative 3 is equals to T is 1. 1 times 3 is 3. So 3 minus 2 is 1. Then 1 plus 2, 3. So it is 1 times 3 times A. 1 times 3 is 3. 3 times A is 1. You remain with? See 3. This is 1. 3 minus 2, the whole of this will be 1, isn't it? Yes. Will be 3. Then A is 1. 1 times 1 times 3. So you get 3. Then go to the next one. T is 1. T is 1. 1 plus 2 is 3, isn't it? 3 times 1 is 3 times B. So that is 3B. Are we together? Yes. T is 1. So 3 minus 2 is? No, the whole of that is 0 because C is 0. So the whole of that term is 0, isn't it? Yes. Are we together? Yes. Because C is 0. So you remain with minus 3 is equals to 3 plus, is equals to negative 3 plus 3B. So look there. What is B? So you bring negative 3 this side. That's 0. Negative 3 coming this side, so you get negative 6. Yes. Negative 3 minus 3, isn't it? Yes. Negative 6. So this implies what? Negative 6 is equals to 3B. So what is B? Negative 2. You divide both sides by 3 to get B, isn't it? So you see we found the value of A, B, and C. We found the values of A, B, and C. Stick to this method because we've agreed that in the future everything you'll be doing will be partial fractions, isn't it? So start where there is A, put the value of A. A we found to be? We found A to be? Where there is B, put the value of B. We found B to be? Negative 2. Where there is C, put the value of C. We found C to be? 0. So it means this term did not exist, isn't it? Yes. That is why we had our difference. Let's proceed. So we've substituted the values of A, B, and C, isn't it? So this is what we've ended up with. This term does not exist, isn't it? So this is what you get when you resolve it into partial fractions. Are we together? Yes. So that is what you get when you resolve into partial fractions, meaning your T squared minus 4 was going to be T plus 2 into T minus 2, a difference of 2 squared, and this was going to cancel with that. That's why it does not exist. So we only have the 2, isn't it? So it means when you are evaluating the integral, of T squared minus 4 dt over 3t cubed plus 4t squared minus, you get this, isn't it? So you just introduce integral in each and every term, dt, isn't it? After doing that, you factorize out a constant, isn't it? You factorize out the constant. So if you factorize out the constant, 1 is silent, isn't it? So that is just dt over t. Here is negative 2. If you bring outside, you remain with dt over 3t minus 2. Are we together? Yes. Then after that, you integrate. So if you integrate dt over t, that is ln of t, isn't it? If you integrate dt over 3t minus 2, that one you get negative 2 over 3 ln of 3t minus 2, then plus arbitrary integration, constant. Look the way this one is coming. When you let u to be 3t minus 2. Are you seeing that? When you let u to be 3t minus 2, then here, when you say u is 3t minus 2, meaning if you differentiate u with respect to x, you get du over dx is 3, isn't it? Then you take dx the other side, meaning du is 3 dx. So it means here is dt, I mean, is 3 dt, isn't it? So it means you multiply the numerator by 3, then you divide by, are you seeing that? So 3 dt is du, then 3t minus 2 is u, so it is du over u, which is ln of u. Are you seeing? And ln of u is ln of 3t minus 2, because we use 3t minus 2. And outside, what do you have? See negative over there. Are you seeing the way it is coming out? Very good. And we have completed that integration process. Are we together? So that is the end of that.